I hope my screen is visible.
Yep.
Okay, great. So today's topic will be understanding streams in Redis. Um, so before okay, so before I begin with the knowledge, here are a few etiquettes that be punctual, provide feedback if required. You can be on mute and avoid any sort of disturbance. So let me jump straight to the agenda. Um, First, we'll learn what are streams. Then we'll see what are the challenges of stream processing. Then we will look at the Redis point of view to streaming, that what approach it brings to the table. Because today we have a lot, many tools, libraries, and frameworks available for stream processing. So how Redis is different and what it does. Uh, in general, we will not be comparing it, but yes, I'll be mentioning few points which are at advantage to Redis than other platforms in general. And in the last, we'll be seeing a demo. I'll try to show the demo in contrast to all the slides that I have prepared, like side by side, so that it's easier to grasp the whole concept. So first of all, let's take a look at what are streams. Now, um, streams can have different definition in different worlds. So for example, here we can see that it's a picture of a 6 or it could be a 9. It totally depends on the point of view of a person or probably the location they are looking at it. Um, we can think of streams as a sequence of data. I mean, for the computer engineers, but for like streams for some other person can be a stream of uh, of a water flow or something different, right? So it has a different approach. And also there is a very old story. I don't know whether anyone knows about it or not. Like there was an elephant and few people were blindfolded and asked to tell by touching that what exactly it is. Some who touched elephant's feet said that it's a tree. Some who touched its tail said that, oh, it's a rope. So it's everyone has their own different perspective when they start looking at any particular topic. But in digital world, a stream is a sequence of data elements made available over time. It's simply an infinite or a finite amount of data bytes that are available over a time, not at a single point of time. There can be multiple sources of streams. First, the request. So it's everything in today's world is actually a stream. All the requests and responses that we receive over our on our application, mobile applications, or it can be calls from customer support. It can be a simple call to DB and a response back, even the logs generated and the reports that are getting generated from those logs. Everything is streams nowadays because this is never ending. We do not have this data readily available at a single point of time, right? Uh, Now comes the next question. That is, what is the difference between streaming and buffering? Uh, I hope many of us have watched a lot of videos or audio files over the internet, and those we think that they are getting streamed from some cloud source to our devices. But is that really streaming? It can be a pseudo streaming called buffering, where there is a small buffer where small bytes of data, which we can call slices, are getting accumulated. Meanwhile, we are processing or viewing that video file or audio file and those kind of things. So buffering is kind of a streaming, but with memory in place. which can buffer it, or we can like just keep some data in there till the time more data is coming in, and we can think or we can uh, feel that it's actually streaming. Challenges of stream processing. So before I go forward, any questions, comments, or feedback till now? Okay, I'll take that as a no. Now, the challenges of stream processing. First one is, of course, slow consumer. Now, let's take a scenario that we need to process probably a large text file, probably like 10 GB, 100 GB, or 1 TB, right? It's like a very huge data that we need to process. Now, we have a processor in place which will do the processing for us and put it into a report or some processed format in DB or any show it in form of a printout or whatever. Now, due to the limited memory, the consumer can be slow than the production rate of data. Now, what will happen in this case? In this case, the data will be processed a lot slower, and it will be limited by the speed of the consumer. And we might even, face situations like Stack Overflow, which is like your buffer has overflown, like we have seen in our previous case, that is buffering versus streaming. So it can cause to multiple error situations, which we don't want, of course. Second issue is a dead consumer, that supposedly our consumer just goes down. Now we will start losing data that we need to process from the point it is dead to the point it is back alive. So we need to resume the stream processing from the last state where we left it off. And the third situation is like, kind of situation for the world today, that we want to share the resources for everything. Like the data can be coming from multiple streams. It can be text files, it can be credit card transactions, it can be anything. And we want to process them separately. Of course, we can't process transactions similar to our text data. Now, these are the different situations that we need to handle while we are doing stream processing. Now, let's go on towards the Redis's point of view to streaming. Uh, First, look at how Redis stores data. Now, messages are stored in the same order as they arrive. How? It's simple. Redis gives each message or each packet of data an ID, which is formed by the timestamp and a sequence number. So for example, here we have like 169-0. It's a sequence number, timestamp. 170-0, because it has a different timestamp, the sequence number doesn't have to be different. But what if two packages or three packages come at the same time? It will start numbering them as 0, 1, and 2, right? And this is how it identifies different messages. So let me quickly switch to the demo part for it and actually showcase, how exactly it works. So I have actually, kept some commands ready so that it's easier for me to do the demo in time. I am using a readily available Docker image for Redis, which comes with the Redis Streams capability, so I can easily use the Redis CLI. I don't have to install anything on my system other than Docker. It's a very clean and efficient way to start using any new software. Okay, so the basic streams is that, like, let's create a very simple uh, stream named emails, where it will have emails having subject like my first email, right? Done. Now here we can see that it has given it an ID of some timestamp and a sequence number 0. Now let's again add Oh, sorry. Again, add the some message, second email, and again see, right? So that this time the timestamp is different, but the sequence number is 0, right? Most of the times, the messages that are received have a sequence number 0 because the timestamp is accurate uh, till the accuracy of milliseconds for now. But it can happen to have different sequence number if the message production rate is too high, right? Like messages are getting produced like thousands per millisecond, which is very, very high rate. Uh, so this is how it stores data in Redis streams. Okay. Now, next thing is having multiple streams. Redis allows us to have multiple streams with different sorts of data. It can be simple events. It can be request responses from user to an application. It can be emails. It can be anything, and all have the same storage format. Uh, uh, and the process of creating a stream is very simple. That you just give it a name and send a message to it, and that's it. We are done in Redis streams. All right. Now, next point is fan out. Uh, so I'm not sure how many of us are actually uh, familiar with the concept of fan out. So it's a very simple concept where multiple messages are being sent to multiple consumers so that those messages can be processed in parallel, right? But with a slight exception that all the consumers will get all the messages. So here, consumer one email, consumer two and three will get all the messages. Hence, the processing happens duplicate, like the whole processing happens duplicately, right? And this concept is simply called fan out. Now, there are not many situations where we need this, but apart from one scenario, which is called uh, a messaging application, where we want to send a single message to multiple consumers, right? It can be simple group chats. It can be sending emails to multiple email addresses. So we can think of those scenarios where we need to send a single message to all the consumers, right? So this concept is called fan out in stream processing. Now the next
And when
thing
you say
is,
and when you say duplication, are you saying duplication just because the same message is being sent to multiple consumers? Because the consumer could be doing different things, right? Consumer one maybe like parses the message, consumer two does something else. But it'll be the same message. I get that.
yes. Not the processing is duplicate, but the process is like the same message is received by each consumer. So it doesn't matter. So for example, like my message one, the consumer one need is just keeping a count that, oh, how many emails I have received
Yeah.
for my processing. So that will be different. Consumer two is trying to extract some phrases from it, right?
Yeah.
And third one is different. So the messages will be duplicate, but the processing can be different. Yes,
Okay.
likewise.
Okay.
Um, okay. Next is pseudo partitions. Now, before I explain what are pseudo partitions, let me explain one scenario, which happens in other stream processing applications. At least in the most famous one, that is Apache Kafka, which is quite popular in streaming world because its performance is next to none, but it has few flaws in it. And Kafka uses a concept called partitions. Now, what it is used for, the question arises, or what exactly it is. So for example, I have a stream named email where I'm just processing emails arriving from a single pipeline or a stream. Now, in order to do the processing in parallel or concurrently or whatever fashion I need to do that, I need to send those messages much faster and consume them much faster. So Kafka has a concept called partitions, where each partition can receive data simultaneously, and the consumer can consume from them from each partition in parallel fashion and speed up the processing process. So that happens, that's called partitions. But in Redis, there are no partitions. You have to create a different stream to to create that scenario of partitions. Now, why Redis dropped this idea of partitions, or why this idea is not good for any stream processing application? Now, the first reason is scaling. Partitions are good for scaling up, but not for scaling down. In Kafka, scaling down is as difficult as removing or re-establishing Kafka itself. Because once the number of partitions increases, you cannot scale them down because you would have the possibility of data loss. You have to wait till all the messages are processed in all the partitions if you want to go down there. But with Redis, no partitions, you can easily stop consuming from a stream or stop sending to a stream. It's up to the user. If they want to increase the number of streams, they can easily do it, right? I'll show that in a demo quickly, that how different streams work here and what exactly is the fan out concept or partitions concept here. But am I clear on the partitions concept, or are there any questions on it?
Yeah, I think what we understand is that there are no partitions. So ultimately, if we need to send out a streaming data and we want to process that in parallel, uh, we need to send it to n number of streams. So just like you have email S1, S2, S3, or S0, S1, S2, those are three different streams, right? So it is up to the
Right.
producer to make the judgment of sending it to 3 or 4 as many different streams.
That's correct. And reason is very obvious, that what if we tomorrow want to scale down for a particular stream? Like for example, this stream can be based on tenants, and one of the tenants stop paying for the subscription, and we need to just stop that stream. In Kafka, it's not possible. You have to delete that whole data from scratch. And we have seen in production that once we reach a particular number of topics or partitions, uh, it just simply dies out. It stops responding. So this is a very big disadvantage with the Apache Kafka right now, which we can easily resolve with Redis streams. So let me quickly.
Himanshu, one more question. Does Redis persist the messages on disk? Are they replayable?
Absolutely. I'll explain how that happens.
One other question. Oh, sorry. Are you going to explain now? Or was that later?
Okay. Okay. So let me quickly explain this fan out and other things. So here I'm doing nothing but creating 3 streams, sending 3 different sorts of data to them. And like we can see that I added all the commands at once, but still I'm getting sequence number as 0, which is, I don't know, way faster, but I can't go any faster than that. But let me try to consume them. We can have one consumer consuming from all 3 streams. That's possible. Like here we can see that it is consuming from all 3 streams at once, right? And or I can have a single consumer consuming from a single stream. It's up to me. But with Apache Kafka, it's not possible. If you have a stream with multiple partitions, you have to have number of consumers plus 1, then the number of partitions. Otherwise, you will simply lose data there. It will start draining from the pipe. The data will simply spill over. So that's the beauty of Redis. It's totally customizable, and very lightweight. I mean, creating a stream in Redis is very cheap. in comparison to Kafka, which takes a lot of, which leaves a lot of footprint on JVM. Right. So, so this particular is a simple example of fan out, right? That a single consumer is actually consuming from multiple streams, or I can have consuming from one stream, 3 consumers consuming from each separate stream. It's up to us. Okay, so let me.
So I'm just
switch back.
thinking, like, so the onus of deciding the number of streams or how much do I want to scale, that lies on the producer right now, right? Should
Really lies. It really lies on the business use case to be true.
Yeah.
Because I can send data to as many streams as possible, and I can consume from any stream anytime I want it. I can have one consumer for all the streams, right? Like I say, okay, I don't have much resources. I will do it through a single stream. I don't have much data rate. I can have one single consumer. Whereas in Kafka, you have to have that many consumers equal to the number of partitions plus 1 in case any consumer dies. So, I mean, this is something which we saw as an advantage in one of our production systems, and it's actually in production for us. That why to use Kafka? Kafka has been a very, very major debt to our platform or to the client's platform, and we simply said we will not go ahead with Kafka. We will just go ahead with Redis. It's lightweight. It's easily compatible with all the languages, programming languages, and it's easily customizable. Okay. So let me switch to the next.
Just a question on the partitions there. You want to? Great, thanks. So does that mean that one stream is dedicated to a partition, or if there's only one stream coming in, will it use all 3 partitions, for example? And does it get mixed up, or is a stream dedicated to a partition?
I do not understand the question fully, but each stream can be used for producing any data and consuming it. I can decide to not send any data to, for example, like S1. I can decide to not send data to S1 anymore, right? And it will simply stop receiving it.
So Julie, there are no partitions in Redis. So I think that is what Himanshu is trying to say. So
exactly.
There is no stream to partition mapping.
Right.
So.
Okay.
Yeah, I mean, it gives a feeling similar to partitions, but it exactly are not partitions. These are simply streams. So
okay.
I don't. Let me showcase that example quickly. So here in stream 0, I'm sending 3 messages, and in stream S1, I'm sending 3 messages separately, and similarly in S2. I can decide not to send messages to these streams, whereas in Kafka, I don't have an option.
Okay, that makes sense.
Right. So it's a very beautiful thing. Really, to me, really, partitions are kind of a technical debt to Kafka, which they cannot remove because it's in their architecture, and it's really a pain.
And how does the horizontal scaling happen here? So is it that the stream gets distributed across nodes, or is one stream just on one node?
Oh, I think what we're talking about here is replication and sharding. Right. I'll come to that later on. I didn't include those topics because I thought it would be a little bit too much to include, but it's quite easy to do it. But I'll explain it once I'm done with other concepts.
Okay.
All right. So let me move to the parallel processing part. Now, what if I want to dedicate one consumer to each stream? Simple. Just create a single consumer and start receiving messages for that stream, right? I just showcased that. A single consumer for one stream, right? And it will start consuming from 0, that is from the beginning. And that's it. You're done. It will just consume from S1.
Yeah.
Right? I can do the same thing for S0 and the same thing for S2. Doesn't matter. And also one thing is quite advantage here, which I forgot about. I don't know whether we can see here clearly or not. The messages are retaining their order, which is a big plus point for Redis, because this cannot happen in Kafka with multiple partitions. We cannot ensure that. Of course, there are ways to ensure it, but that reduces the performance. Whereas in Redis, I don't have to do anything else. I don't have to give any separate command, right? So payment received, order shipped, order delivered. And if I show the messages like order that I sent it, it's the same. So it keeps the order of the messages automatically in um, in a timely fashion there, in chronological order. I don't have to do anything else. So that's another advantage to Kafka that we have. Okay, now the next thing is parallel and in-order processing. Basically, it has all these things inbuilt, that whatever messages we are going to send it into Redis, they will retain their order no matter how many times I retrieve it, no matter how many times I try to process them. It will always be in order, right? Of course, but we have to use multiple streams for that purpose and different consumers if you want to process them separately. Next big concept in Redis is consumer group. What is a consumer group and why do we need it? A consumer group is nothing but a bunch of consumers which are aware of each of every other consumer's state. They know what the other consumer has processed, and they have to leave that message and jump onto the next one. So here, consumer 1 is processing the first and the fourth message. Consumer 2 is processing like maybe third and the sixth message. And consumer 3 is processing like second and maybe the fifth message here. So they are aware of each other's state right now. And that's why consumer group is quite efficient if we don't want each consumer to be processing each message, right? We want them to happen fast and very, very, I would say efficient manner. That, oh, I have multiple consumers now, then why are they not processing in parallel? It looks like they're parallel, but they're not processing in parallel, right? So that's what a consumer group is. Let me show an example for that one too. So let me create a group for that. It's an email application group, very simple group that's created. And let's send some messages into the email stream there. And let's start reading it, right? So I can see that my first email has been read, right? Now, what if I go ahead and use another consumer? It will read my second email and go ahead and read the third one. Again, this one, my third message. It's easy, right? Of course, it's not reading them in order because I've already added 2 messages to my other stream, right? So that's how a consumer group works. Each consumer will consume different message than the other one. And that's how it keeps a state of each consumer in that group. So for example, like if I go ahead and ask from 1 again, it will pull the fourth message for me. But what if I, try to ask consumer 3 to pull that message? It will pull the fifth message for me, right? It will not pull the sixth message because it's the next one in line to pull a message from the pipeline. So it totally depends on which consumer is available at that point of time. It will simply go ahead and pull those messages. Now here is one difference, another difference from Kafka that I would like to highlight. In Kafka, there are multiple partitions, right? And each consumer is assigned to each partition in Kafka. And that's, again, not efficient. What if I have 10 consumers and 5 partitions? My other 5 consumers might be just waiting idle. Maybe 6 are waiting idle, right? That's not a very good resource utilization for me. Again, a lot of wastage of the resources in Kafka, not a good idea. So this again here is a positive point for Redis.
Is there any way that a message read fails?
Yeah, absolutely. Message read can definitely fail in Redis. I haven't been able to replicate that kind of a scenario because I think that the rate of data should be high. And so, for example, like what if while reading it, it's just not able to read it, right? Or my system dies or processor dies. It can happen anytime, right? Uh, and I think that's what I'm going to come to next. But I'll explain how that can be handled easily. Another thing, there can be multiple consumer groups associated with one single stream, right? So likewise, I created one group consuming from one email stream. I can have 2 consumer groups and even a standalone consumer processing it, and collectively they are like developing one single dashboard or one single report for me. Like this one might be processing some revenue data, this one might be processing some costs or expenditure, and the third one is from departments, like department data, and I have a total report at the end of the day. So one single stream is not restricted to just one consumer group. It can any consumer group can consume from any stream at any point of time, even standalone consumers. In Kafka, this is also possible, but not recommended. So uh, that's how Redis helps us multiple processing. Oh, not with multiple consumer groups at once.
So if you have multiple consumer groups in a single stream, right? So does you have to explicitly specify the fan outs, like how many fan outs will be there for each of the consumer groups, or it will be automatically deduced?
Fan out, you mean that every consumer group should process each and every message?
Yeah, I mean there's a single stream, right? So there are 5 like in consumer groups there are 5 consumer, right? So
you don't have to. You just have to tell Redis what's the last message you processed, or just process all of them. Simple. You can decide. So for example, for consumer group 1, it will start processing from 1 or 169.0. For consumer group 2, it will start processing from 169.0. Standalone consumer, it can start processing from 169.0, or it can start processing from 172.0.
okay,
The
so
choice
offset.
is on the consumer. We can,
Mm.
yeah, absolutely offset. Yes,
Okay.
absolutely. I haven't tried the offset strategy in Kafka yet, so I'm not super sure about it. But with Redis, message offset is the key to get to the next message. Without that, I think we are pretty much lost and we have to begin from zero. So that's the case here.
Yeah, but yeah, there will be some offset.
Oh yeah,
And like
absolutely.
yeah, in Kafka.
So the offset is, yeah, I think that's a good question. Let me show you. So for example, I have, okay, oops, um, right? So I add a message to a stream called email. It will provide me a key in return. So this is the return type. This is the offset for me. Every time I add a message to Redis, it provides me an offset, which I can use as a reference to start beginning my processing. So for example, like if I want to read it, I can even, yeah, this, no, not this one. Okay, I can use that as an example there. Then, for example, I want to read from email stream, right? Beginning from this offset, I'll just use it and that up. Okay. So I just need to provide the. Okay, that's probably that's different, but yeah, we can definitely provide the offset here, and it will read the messages after that for me. Or I can use any other offset probably. I'm not super sure, but I have to read it again. Oh yeah, absolutely. So that was the last offset. That's why it was not reading. I'm sorry about that.
Yeah, no
But
problem.
any message after this offset, you can easily read them, and you can see that I've got my latest message that I added there. Second, third, hello Himanshu. And this offset was for the first email, I am assuming. Yeah, for the first email. Here, this one. So it will read after that.
Thanks, Himanshu. Yeah,
You're
wrong.
welcome. Okay. Again, multiple streams, multiple consumer groups. We can customize it according to our needs. You don't have to be bound by any framework or library constraints here. Last thing is fault tolerance. I think there was a question raised by you around that. How does Redis actually recover from a failure, or whether it persists that data or not? It does persist it but where? I'm not exactly sure. Maybe in Redis itself, because Redis is a very popularly known database, key store database. So it handles fault tolerance using 3 strategies. One is at most once acknowledgement, where the consumer provides acknowledgement as soon as it receives the message, even before it processes it, right? I think I have a missing word here. Then there are at least once, where the consumer will commit only after processing it, but it can be a case that it might process that message again, right? So there is a possibility there. And the last one is exactly once, where it ensures that each message is processed exactly once, exactly one time, right? But with each strategy, the throughput starts decreasing because Redis also has to keep in mind about the state or the last process message it has processed. To overcome that, most of the consumers or most of the applications just keep the last state in memory, that okay, this is the last state or last offset where they were, and not exactly use these strategies. And I'm saying that because we use that kind of a strategy. We don't use any acknowledgement. We just keep the last process offset in DB, and that's it. We are done. So that strategy we use because we want the maximum throughput. We are not worried about any kind of data loss here. So we can use any of these strategies. But how does these strategies work? For each consumer, there is a list called pending list kept in memory by Redis. I should not use the word memory here, but it is kept by Redis to know where they have failed, right? And also it keeps information about the last delivered ID or the last delivered offset of the message by all the consumers or each consumer, right? So here we can see the consumer 1 has processed 1609170, consumer 2 has processed 170, and consumer 3 has processed 171 here. So this is how they can pick up from where they have left off. And this is applicable to each consumer. So for example, consumer 1 fails for message 1, it will reprocess it, right? Here, likewise, consumer 2 fails, it will reprocess it. Consumer 3 fails, it will reprocess it. It doesn't matter whether the other consumers have forwarded or not. That will just update my last delivered offset, nothing else. So that's how we can ensure that that my messages are actually processed and there is no faulty results. And there is another way to do that again, and that is called process set in Redis. This set keeps the information about all the messages which have processed. It is kind of a similar to this last delivered offset, but that only points to the last message. It doesn't keep a set of all these messages which have already been processed. So we can use this strategy as well, but this strategy is used primarily only for exactly once case, that each message should be processed only once, irrespective of their consumer. So this is another strategy.
So when we say exactly once, does that mean that across consumer groups as well, it will be processed only once?
Exactly, yes.
Okay.
Because this process set doesn't know about the consumers, that is kept separately by the pending list. So where a consumer has left, like for example, consumer 1 left at first message itself, it will start processing from the first message, right? But the process set says, oh, I haven't received 1690, so that message might not have been processed yet. So in that case, consumer 1 will again go ahead and process it. So, yeah. For at most once and at least once, we can use just the pending list, but for the exactly once, we primarily use process set. I can show this particular scenario here. So for example, like let me showcase this an example. Sorry for that typo. So for example, in that email group, I take, okay, let me take the first one. So, yep, this one. And say that just acknowledge that I have already processed this message. Now I'll go ahead and try to read it again through the consumer group, right? Oh, sorry, just through a consumer, right? That this message has already been acknowledged. Oh, wait. It should be just the. It should be just that. Right, it should be from the group. Sorry for that confusion. Yep. So, okay, let me try to read all of them. No, right, because I have reached to the last of my message. So let me try to add another message here to my email. The email. Right, and let me try to read it. It has been read. Now I want to acknowledge for it. I'll simply go ahead and say just acknowledge its ID for me. Right, and since it's already been read, I will definitely get an empty there, but let's add another message and see whether I'll receive both of them or just the last one. So it can be next email. So let me try to do this. And this, of course, I won't be getting that acknowledged message again in my email group. So that's how it keeps the idea about what message has already been processed. So I think I have already covered the demo pretty much along with my concepts on the slides. But if there are any other questions related to Redis, I am happy to answer them.
Just
Yeah,
a
no,
quick reminder, it's 1 minute past the 45-minute mark. So
yeah, we'll just end in 2 minutes, Inga. Thank you. So Himanshu, what kind of, so I know that you are using it in one of your live projects. So what kind of consumers are we really talking about? And if you could just talk about, so are you using consumer groups? Are you using just consumers? Are you sending out the messages to different streams? You know, like, I'm just trying to understand because, you know, whatever we do with Redis streams, we could possibly do that with Akka as well. You know, like, I'm just trying to understand when would I use one versus the other.
Right. First thing that gives an advantage to Redis, it can be used as a hosted service like we do. AWS, Azure, Google Cloud, they all have platforms for Redis readily available. It doesn't matter what platform we choose. Akka streams, again, licensing, huge cost, a no-go definitely for me. But we do use Akka stream, so I cannot say that, but that's a legacy now. Now, Redis streams where we can use it in comparison to Kafka or Akka streams. I can do definitely these sort of things from in other platforms as well, but they have their own pros and cons. With Akka streams, I see one issue a lot, and that is it doesn't scale very good if we don't use Akka clustering. So it is dependent on clusters, right? It is dependent on the concepts of Akka clustering. I cannot scale it out horizontally if I don't use it. Akka streams is totally based on the concept that you use Akka clustering and sharding.
Yeah, that's the reason I asked about sharding earlier, because they'll also have to do something similar, right? You know, like once the
Exactly.
stream gets beyond a node.
Exactly. So let's take a scenario that we have maybe 1,000 streams in one Redis machine. It is a single node machine. There are 1,000 streams. I can easily support it. But what if I have to now, I have added another machine to it, then it will do rebalancing to the next machine. That 500 or maybe 400 of them are shifted to the new one. Now, what if I scale vertically up to those machines? Now that will do resharding for me, right? And that happens inside the Redis cluster, which is totally, I would say, opaque for users. We don't have to worry about it. It's already hosted. I don't care. Reduces the job of DevOps team, reduces a lot of cost for me to maintain it. Apart from that, no licensing fees, nothing. It's just a hosted service for us. And the last thing is our scenario where we have to use it. It was we don't care about message failure. Like if a message is lost, we are okay with it. We don't care about it. We just care about the throughput, right? So we didn't go the Kafka route because Kafka is pretty heavy in operations. It needs Zookeeper, which is again hard to maintain. It needs a lot of other services, like Zookeeper needs 3 nodes, Kafka needs 3 nodes, total 6 nodes. I mean, why? It's not worth the cost. But of course, the newer versions of Kafka, I think after 3.1 or maybe 3.3, I don't know, they have introduced something called like Kafka Craft, which doesn't need Zookeeper anymore.
Yeah.
But again, upgradation cost is way too high. If any organization today decides to upgrade Kafka, they will have to pay a lot of money to the vendors, to the engineers, and it will take months to do that. So that's again a cost there. Whereas Redis, I can go to AWS, I have a host or a server ready within few minutes, and I'm up. I don't have to think much about it there. I think this is the pretty much the same reason we, I mean, another scenario, we let Cassandra go and use RDS, because Cassandra, again, is cluster based, not worth the cost. We can easily lose the historical data. We don't care about it because we just need the last state. That's it, which we can keep in Redis as well. So Redis has proved a lot to our platform. It is lightweight, it is easy to maintain, and like costless in terms of operations.
Yeah. No, it's not. Yeah, like it looks simple enough. I'm just trying to think, like, so probably that's a different discussion. But
right,
would I not be able to achieve similar things with something simpler, like like RabbitMQ, or because ultimately what am I getting here? Like I'm pushing to different streams. I don't know if like all the bells and whistles of consumer groups and like other kind of things exist with RabbitMQ or not. But I'm pushing to different streams, so the producer needs to be responsible for that. Then I'm building my consumers who are reading out of those streams. Now they can read out of the combined stream or individual streams. And it looks simple, yeah. Like I'm just trying to think, comparing it with the solutions that we have used in the past. Like where does this one come in handy as compared to them?
So I'm not super sure about RabbitMQ. I haven't used that in past, but I can definitely compare with Kafka. Kafka is like pretty much a box made out of iron, and I cannot mold it. But with Redis, I can easily mold it, or can just throw it away and use the another chunk of clay to mold another box out of it. Because like I said, I don't need partitions. When I don't need it, I will not use it. Kafka doesn't give me that option. And there have been scenarios for us where we have to clean the whole Kafka clusters, start from the scratch, because it was totally out, like unresponsive for us. And it was handled by a third party. Even then we have to do all those things. So it's really not worth the cost. Maybe RabbitMQ or Akka streams can have different pros, but I like Redis after using it. And for a lot of other communities like Java, Scala, they have added new clients like Redison. Redison is the latest client through which we can even use it in our applications easily. So we are using Redison right now.
I think if your application, I mean, if you are looking at streaming, I think it totally makes sense. But look from an enterprise message bus perspective. I mean, if you have a large message bus that has to serve multiple teams, multiple business units, multiple countries, and you are looking at all these ecosystem, like for example, Kafka comes with connectors. Kafka comes with schema registry. And Kafka comes with replication, Kafka comes with access control, encryption. I don't know how much these tools will fill all those gaps. I think, if I'm a company, I need one solution for all of these. I don't want multiple solutions by multiple teams. We need to go into all those details, right? It is not just performance. I mean, performance in a single application. Recently, I'm hearing Pulsar as a good competitor because its architecture is also pretty close to Kafka. But I don't know all those details about Redis, but I can see the advantage.
Yeah, that's the fun thing. I think like we get bored out of one technology, and then like we want to look at something else. So Kafka is getting out of flavor. Then there is compare it with PubSub, compare it with Pulsar. Now we have Redis streams. We already had Akka streams, and yeah. So I think ultimately it just boils down to the use case and like what kind of application we are building. What is the appetite for the kind of the things that you mentioned, like authentication and schema registry and others that the application needs. Otherwise, just go ahead and use something simpler like Redis. And what I understand,
Right.
this is open source, is it, Himanshu?
Absolutely. And the beauty about it is that if we are worried about authentication and encryption, then in AWS everything is encrypted, so we don't have to be worried about that. For enterprises, it is always there, because for the client from whom we are using it in production, they are in security space, so they are using Redis heavily in their platform. But again, it totally depends on use case to use case. Ours was simple messaging like library or framework, which we can use and probably play with it easily, irrespective of going into the details. Like, so we did had an instance with I think it was Confluent for Kafka, and we had a meeting, and they suggested a lot of things to optimize the performance when we were not getting the maximum performance. I mean, why? Why do we need that kind of consultation? We can do it on our own, right? If it would have been easy, we could have done on our own. But why is it so complicated? Why so many partitions? Why TTL is there? Why everything is there? So in fact, it's so flexible that we have actually added TTL to Redis now. Of course, that's a custom solution that we are building, but we can easily mold it. That's the beauty of it.
Sounds good. No, yeah, it sounds exciting. Yeah, and I know Inga's going to shut us down if we go anymore. So
okay, so just the last things that these are my references and where I got information about Redis. And
you are using it with Java, is it?
We are using it with Java, but it is available for other JVM languages.
Got it.
What about Python?
We can use it with Python as well. They have a
Python, I'm
Python
sure
client.
every tool works with Python.
That's true. Yeah, otherwise it won't graduate.
Yeah, exactly. Yeah.
.NET, C#, everything.
Wow. All right. Sounds good.
Okay, everybody.
Cool.